Let's try to solve a problem which is related to Max Planck's quantum theory. Max Planck was a German physicist, and in the 1900 he proposed a term called quantum, according to which the smallest quantity of energy that can be emitted or absorbed by any hot body is proportional to the frequency is proportional to the frequency of that is proportional to the frequency of the energy that it will generate it. So energy that is released is equal to is quantized. It cannot have any volume. It will have it will be the integral multiple of h into nu. So like energy or quantum or quanta of energy is equal to, it should come in packets and its value should be equal to it's proportional to the frequency of the light that is emitted or absorbed, and it will be equal to energy of one photon or one quantum will be equal to h into nu, where h is the Planck's constant, and it has a value of 6.626 into 10 to the power minus 34 joules second. The question says that calculate the energy of 1 mole of photons of radiation whose frequency is 5 into 10 to the power 14 hertz. 5 into 10 to the power 14 hertz, I think it comes in the visible spectrum. It's yellow light. And for this we need to calculate how much will have one photon 1 mole of photons will have how much energy. First we'll calculate one photon will have how much energy. Then the amount of energy in one photon, that means it should be is given by E equal to h into nu, where h is a Planck's constant and nu is its frequency. Since it is yellow light, its frequency is 5 into 10 to the power 14 hertz, and the Planck's constant is this. The Planck's constant has unit of joule second, and it has hertz means per second. So second and second will be cut off. What remains is joule. So this comes to 33.130 into 10 to the power minus 20 joules. This is the energy present in one photon of yellow light, one packet of yellow light. And energy, it cannot have energy from any from any body which radiates electromagnetic radiation should be the integral multiple of this value of this photon. It cannot have any other value. That means the energy released from a black body or when charged particles are accelerated should be in the multiple of this value of one photon. But we need to calculate how much energy is present in 1 mole of photons. 1 mole means how much? It's Avogadro number, 6.022 into 10 to the power 23 moles, 23 photons, right? So it's this multiplied by, this is the energy in one photon multiplied by Avogadro number. So it comes to 180 kilojoules per mole. 10 to the power 4. If you want to replace this by kilo is 10 to the power 3. So 1 0 remains. It adjusted here, it's become 180. So 180 kilojoules per mole. That means this, if for for electromagnetic radiation having this much frequency, 1 mole of photon will have this much energy, 180 into 180 kilojoules per mole. I hope it's clear.